Hi, how's it going? Welcome to Code with Z. In today's video, we have to find the minimum in this array. Why? Well, because that's what LeetCode 153, find minimum in rotated sorted array, is asking us to do. Now you might be like, what is a rotated sorted array? I'm glad you asked. Let me first explain this with an example and then we're gonna come back to the question. So this is a normal sorted array. As you can see, we go from 0 all the way to 7. If we want to rotate this array one time, we're gonna get the last number that we have here and put it in the beginning, like so. As you can see, we took the 7 from here and put it here. Now, if we want to, for example, rotate it twice, we're going to take this number and put it in the beginning. And that's going to make our array be rotated twice. So now let's get back to the question. As you can see, it says, suppose an array of length n, so for example, this array that we have here, sorted in ascending order is rotated between 1 to n times. For example, the array, this is the array that we rotated twice, so we go from 0 to 7, might become this array if it was rotated 4 times, and might become this array if it was rotated 7 times. So it's just basically telling us what we just saw, how the rotation works. As you can see, it says, bring the number from the end of the array to the beginning of the array. This is what this part is basically telling us. And then we have the question. It says, given the sorted rotated array, which is called nums, for example, this array that we have here, which is rotated, return the minimum element of this array, and we have to solve this in log n time complexity. Now, I don't know about you, but anytime I hear log n, array, and sorted, I immediately think of binary search, because binary search helps us to find the number that we're looking for in log n time complexity. But the problem is we don't have a normal array. We have a rotated sorted array, as you can see. And binary search only works with properly sorted array. So the approach is basically gonna be binary search, but we have to make some minor adjustments to it so that it will work with our array. So since we have binary search, let's add the elements that are basically related to binary search. So for example, we need a variable called left, and this is going to be equal to 0, meaning it's going to be pointing to the position of the first element inside of our array, which is 0. The position of this number that we have here is 0. The index of this number is 0. And then we're going to also have right, which is going to be equal to the index of the last element inside of our array. So the last position inside of our array, and it's going to be pointing to this position, and it's going to be equal to, well, let's see, 0, 1, 2, 3, 4, 5, 6. So right is going to be equal to 6. Now that we have our left and right in binary search, we also need another pointer, which is called middle, and it's just equal to left plus right divided by 2. So basically the middle point between left and right. So for example, left is 0 and right is 6. 0 plus 6, that's going to give us 6. 6 divided by 2, that's going to give us 3. So middle is equal to 3. So middle is equal to the position of 3. Well, the position of 3 is going to be pointing to 7. Why? Well, because the index of this number, of this 7 over here, is 3. Let's check. 0, 1, 2, 3. And that's why middle is pointing to 7. Now that we have our left, middle, and right pointers, this is so far textbook binary search. We need to add the minor adjustment. Let's zoom out and think about what we're doing. We want to find the minimum number. If this array was properly sorted and we had no rotation, the minimum number would have just been the first number inside of the array. So it would have been the number that left is pointing to, right? Because we go from the smallest number all the way to the biggest number in a sorted array. And prior to the rotation, this array was properly sorted. But now this is not the case. We have rotation, but if we actually take a look, if we look carefully, we can see that this part of the array is actually sorted. We have 4, 5, 6, 7, and this part of the array is actually sorted. So even though we have rotation, it's not like we put the numbers in random order, because we had the array sorted in the beginning. Even though we actually rotated, we can still find some signals and some signs of the sorted array. So because of this, we can come up with this approach. We're going to say, I'm going to show you the structure now, and then I'll visualize the whole process. So just hear me out here. We're going to say if nums at the index of middle, so basically if the number that middle is pointing to is greater than the number that right is pointing to, go to right. But why? Like what is this saying? Well, if we think about it, we're saying if the number in the middle is greater than the number on the right, that means the numbers on the right are gonna be smaller, because we already know if the middle is bigger than the numbers on the right, that means the numbers that are smaller than the middle might be on the right side. And because we're looking for the minimum, we're gonna say go to right. And when we say go to right, we say left should be equal to middle plus 1. So we're gonna bring left to here. Why? Well, because we want to ignore everything that we have on this side. So we're basically trying to minimize the area that we searched at. So if that was the case, we're going to do that. And else, meaning if that was not the case, we're going to go to the left for almost the same reason. So we're saying if the number that middle is pointing to is not greater than the number the right is pointing to, that means the numbers on the left side might actually be smaller, and we're looking for the minimum. So we're going to explore this part. But there's a difference. We're saying right should be equal to middle. So we're not saying right should be equal to middle minus 1, meaning we're going to bring right to here, not here. Why are we doing this? Well, let's explore this. Let's open this else up. Previously we said, so our if statement was that if the number that middle is pointing to is greater than the number that right is pointing to, left should be equal to middle plus 1. But the else actually means if the number that middle is pointing to, I'm basically showing you what the else means, is smaller or equal, we also have an equal, to the number that right is pointing to, right should be equal to middle, because we don't want to exclude the middle number. The middle number might be the smallest number, we don't know. So instead of saying right should be equal to middle minus 1, we're going to say right should be equal to middle, because we want to also explore middle when we look through the array for the number that we want to find, which is the minimum number. Alright, so let's go back and let's start the visualization. So we have our left variable, we have our middle variable, and we have our right variable. So we're going to check if the number that middle is pointing to, which is 7, is greater than the number that right is pointing to, which is 2. So is 7 greater than 2? Yep. Alright, let's go to the right. So left should be equal to middle plus 1. Middle is 3 because the position of this number, the index of this number is 3. 3 plus 1, that's going to give us 4. So left should be pointing to the number with the index of 4, which is 0. Alright, now that we have this, we have to recalculate middle again, because this is going to be a loop and we're going to keep on looping as long as left is smaller than right, and left currently is smaller than right. The value of left is 4 and the value of right is 6. 4 plus 6, that's going to give us 10. 10 divided by 2, that's going to give us 5. Well, now middle should be pointing to the number with the index of 5, which is 1 over here. And then we have our if conditions again. We're going to keep on looping as long as left is smaller than right. So let's again check this. We're going to say if the number that middle is pointing to, which is 1, is greater than the number that right is pointing to, which is 2, go to the right. Well, 1 is not greater than 2, so we're going to fall inside the else. We're going to say else, go to the left, meaning right should be equal to middle. So right should be equal to middle, like so. Now right is pointing to this, and then we have to recalculate our middle because again, left is smaller than right, and we want to keep on looping as long as left is smaller than right. Let's calculate this again. We're going to say middle is equal to left plus right divided by 2. Well, left is 4, right is 5, because the position of this number, the index of this number is 4, and the index of this number is 5. 4 plus 5, that's going to give us 9. 9 divided by 2, that's going to give us 4.5. We don't want this decimal here, so we're just going to ignore the decimals, and we're just going to keep 4. Now middle is equal to 4. So middle should point to the number with the index of 4, and that's going to be 0 over here. And then again, we're just going to ask our simple questions. We're going to say if 0, which is the number that middle is pointing to, is greater than 1, which is the number the right is pointing to, do the following. Well, 0 is not greater than 1, so we're going to fall inside the else. In the else, we're going to say go to the left, meaning right should be equal to middle. Right should be equal to middle, as you can see. And then we want to keep on looping, but left is not smaller than right. They are equal. So now that we're actually exiting our loop, we're just going to return the number that right or left is pointing to. It doesn't matter because they're going to end up pointing to the same number. So for example, we're going to return the number that left is pointing to, and that's going to be 0. And if you check, 0 is actually the minimum inside of our array. So that's going to be how we solve it. Now let's code this in the simplest way possible. Alrighty, let's code this together. So literally the same thing that we saw in the slides. We're going to say we need a variable called left. So this is going to be equal to 0 because that's going to be the index of the first element. And then we need a variable called right, and this is going to be equal to nums.length minus 1. And this is going to be the index of the last number, the last element inside of our array. And then we're going to have a loop. We're going to say we want to keep on looping as long as left is smaller than right. And here we're going to say, let's get the middle. We're going to say const mid is equal to left plus right. And then we want to divide this by 2. So left plus right divided by 2. But we don't want to have any decimals. So we're going to say math.floor to get rid of the decimals. And then we're going to wrap it around this. And then we're going to have our two simple conditions. We're going to say if nums at the index of mid is greater than nums at the index of right, left should be equal to middle plus 1. And then we're going to have our else. We're going to say right should be equal to middle. And then after this, at the end, outside of our loop, we're going to return the number that right or left is pointing to. Doesn't matter. I'm going to go with left. We're going to say nums at the index of left. Now let's run this and see if we can actually get accepted. Let's see, and we got accepted. Awesome. Now let's submit this and see if we can actually pass all of the test cases. And yep, we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.